Today we are continuing on in the unit 721 proportionality. And then on your notes, when you fill that out, please also make sure to add your name and today's date. And we do have a correction to make. Please fix this to say lesson number 3. I can determine proportionality from graphs. So yesterday we focused on tables. Today we are focused on graphs. And to start off, you actually have a warm-up that you can do on your own. So you need to find the constant of proportionality. Pause the video, answer the 2 questions, and then come back to check. When we think about what we learned in our previous lesson, we know an equation for something that's proportional is y equals kx. Whatever number is this k value is our constant of proportionality. So in the first problem, A, the constant of proportionality is 4. And in the second problem, our constant of proportionality is 1/3. So our first problem is asking, is the table proportional? Why or why not? And if it is, we're going to write an equation. And then we're also going to try graphing. So with this first problem, remember to find is it a table is proportional, we're always going to do y divided by x. And notice this table is going across. So the first that we see is x, so the top is x and the bottom is y. So when I think about proportionality, we're still going to be dividing each of these values y divided by x. So I'm going to have 2 divided by 1, which is 2. 4 divided by 2, which is 2. 6 divided by 3, which is 2. 8 divided by 4, which is 2. And 10 divided by 5, which is 2. In each case, we got a constant of proportionality to be 2, so it was consistent. So is this table proportional? Yes, because we had the same constant of proportionality of 2 in the table. So I had that consistent constant of proportionality. And because it is proportional, we can write our equation. Remember, it's going to be y equals something x. That something is going to be our constant of proportionality. In this case, it's 2. So y equals 2x is the equation. So we know this is a proportional relationship, so we are going to graph it to see what that would look like. Remember, x goes across the bottom, so it's the number of pens. Remember, graphs have to have labels. And then up the side is cost. Notice this one's already numbered for you to make it a little easier, so all we have to do is plot these different points. If I get 1 pen, it is $2. 2 pens is $4. 3 pens is $6. 4 pens is $8. And 5 pens is $10. And then if you have a ruler, please get that out or find a straight edge. Yours is going to be nicer than mine. But we are going to connect these dots in a nice straight row with that line. And that line, we're going to put arrows on it to show that it goes on forever and ever. And that should be nice and straight, that you use something straight to draw it with. We have another problem very similar to the last one where we have to figure out, is it proportional, why or why not? Write the equation, make the graph. And so when we look at this table, it tells us x and y. So remember, it's always y divided by x to find the constant of proportionality. And when we look at this first row, it has a 0. So like I've said before, I don't really like to use that row to figure out constant of proportionality, just because it's going to throw off my numbers. Because 6 divided by 0 can't happen. So why don't you find out if this table is proportional on your own And if it is, write the equation. And then we'll come back and we'll graph this together. So pause the video, figure out if it is proportional, and then come back to check. So looking at this table, when I divided my first row of 9 and 3, I got 3. Then my second row is 12 divided by 6, which is 2. Right there, because these numbers were different, I already know that no, it's not proportional. And it's because each row had a different ratio. So here my vocabulary that I used was that word ratio, which works. And then because it's not proportional, we cannot write the equation. But we can still graph. So looking at this graph, we first need to make sure there's labels. In this case, we don't have labels, we just have X and Y, and that's okay. And then we're gonna go ahead and put these values on. And we can graph that first row. Even though it doesn't help us to figure out proportionality, we can still graph the 0.06. Then we have the 0.39. 9 is between 8 and 10, so we kind of have to estimate. 6, 12, 9, 15, and 12, 18. And then using your straight edge, connect these dots and make sure that you put arrows on the end. And notice in this graph, it is not proportional. So what I would like you guys to do is looking at the first graph that we made that was proportional and the second graph we just finished that was not proportional. What do you notice about the characteristics of a proportional graph? All proportional graphs have two very unique features that we have to check for each time we look at them. See if you can make any predictions about what those two are going to be, and then I'll come back and tell you the solutions. So the first characteristic of that proportional graph versus that one that was not proportional that I noticed is that the first one goes through the origin. Through the origin, or the 0.00. All proportional graphs are going to go through the origin. The second thing that all proportional graphs will be is they are a straight line. So both of our graphs had a straight line, but only the first one that was proportional went through the origin, and that's what made the distinction. So down below, we have our graphs already set up, and we have two different tables. All I want you guys to do is graph the data and figure out if it's proportional. And then, obviously, why or why not. So using the vocabulary, explain why or why not. So why don't we graph both of these and then come back and look through answers together. So if you've graphed both of these, it's very easy to tell which one is proportional and which one is not. This first one, right here, we can see where it crosses my y-axis, and it does not go through the origin. So this is not proportional, and then it's because it doesn't go through the origin. Using that vocabulary, but also being specific about why it's not proportional. And then looking at that second graph, is it proportional? Well, it does cross through that origin. It is a nice straight line. So yes, it's proportional, and it's because of both of these things. So we have to specify both those reasonings. Yes, because it's a straight line. That's one reason. That goes through the origin. Notice we used both specifications, 1 and 2, that make up proportional graphs to give that explanation, so it's nice and thorough. We have straight line through the origin. We need to have both of those when describing why a graph is proportional.